Alright guys, so we've got my neighbor's 2004 Jeep Wrangler, and he's got a couple problems with it. No check engine light, but about 6 months ago he had a code popping up for a cam sensor, and I replaced the actual sensor, and when I pulled it apart, the magnet actually just fell out of it. Well, the new one that I put in it is working and everything, but it's ticking. Whenever it runs, you can hear a tapping sound coming from this. This is the synchronizer shaft, the Camshaft Synchronizer. So he just bought a whole synchronizer. You can get these for about, I think, like 40 or 50 bucks, because he wants a brand new one in there. So I'm just going to go ahead and put that in. And his other complaint is whenever it warms up, the idle is a little low. So I've got the launch hooked up. And the one thing, so one of the things that you want to check as far as when it comes to idle is obviously vacuum leaks and stuff, but also the IEC motor. The IEC motor, the idle air control motor, is a stepper motor that controls how much air flows through this little opening right here into the engine, and that actually causes the idle to increase and decrease depending on where that IEC motor, that stepper motor, is commanded. You know, if it's commanded closed, it's shutting off the air. If it's commanded open, then it's adding more air to the engine. And there's usually a function on these scan tools that allow you to run that IEC motor. And I'm right here in the scan tool, as you can see. And let's see. Idle air stepper motor. Okay, I can hear it. So it says that it started. Now, some vehicles you can actually manually bump it up and bump it down. Hopefully you can hear that. That's the stepper motor opening and closing. And I guess on this vehicle, that's all that particular test lets you do. And you can actually take that out. You got to hold your finger on that pintle so it doesn't shoot it all the way out the end. But you can actually watch it open and close. So let's go ahead and stop this test. It is out there running. Tells me that the wiring is good. So let's see what other tests we got. Okay, we got some RPM. Okay, so this is going to work. So you see these RPM, set RPM at all these different ranges. Well, that's the function of the IEC motor, idle air control. So if you've got an idle issue and you command it to, like, bump it up to 1300 or 1600 or 900 or whatever, and if it's not able to do that, that would be a suspected stuck IEC motor or a wiring issue that even though it's trying to command the IEC motor, it's not going to. Now for this test, you got to have the car running, so I'm going to start it up. And it's cold right now. I don't want to warm the engine up too much because I've got to change that synchronizer shaft. But we're set, I mean, idle-wise, we're right on the money. I would say we're pretty close to where it needs to be. But basically what I'm wanting to do is make sure that IEC motor is able to control the engine at whatever RPM that I set this to. So we're right at 900, so if I hit 900 and hit start, probably not going to do a whole lot. So let's go back. I'll go ahead and hit, we'll do 1500. Hit start. 1500. When I hit stop, we'll go back, we'll go to, we'll do 18. So that IEC motor's working. Seems to be working fine. We'll just do 1,000. And it bumped it right up to 1,000. Hopefully that's all coming through for you. I'm going to hit stop. Okay, so now at this point, I verified that the IEC motor's fine. I was concerned. This vehicle's got 252,000 miles on it. I thought maybe, you know, if it's the original IEC motor, it'd be having issues, but it seems to be working. So I'm going to go ahead and kill this engine so it doesn't get too hot for me to work on. And I don't know if you could hear that ticking. I mean, I can hear it from in here whenever it's running. You hear that synchronizer shaft ticking. I don't know if it's actually contacting the sensor. That's my suspicion, because like I said, whenever I pulled the old sensor off, the magnet was actually, it was knocked out of its housing. And I think that synchronizer shaft's just got a lot of wear on it, and it's tapping that magnet, and it knocked it loose, which is why we're replacing that. So I'm going to go ahead and start replacing that, and I'll show you how that goes. And then at that point, we can warm this engine completely up, and I won't have an issue. I don't want the engine hot while I'm trying to replace that shaft. It'd just make it that much more miserable. So let me get set up to replace that shaft. Okay guys, the first thing you need to do is get the engine on top dead center of the compression stroke. So I'm going to pull this coil housing off, which is just these 4 bolts right here. You got another one back there. This whole housing will come off, and then I'm going to take the number 1 spark plug out, which is the very first spark plug right here. Okay, so I've got a 19 millimeter. I'm going to be down there on the crank with a ratchet. And all I'm going to do is put my finger over the hole, and I'm going to turn the engine over by hand until I feel pressure try to blow my finger off. Or push. It's not going to blow my finger off. It's going to push my finger off of that hole. The way we're going to adjust this using the scan tool does not affect the ignition timing. The ignition timing is completely controlled by the computer. The adjustment of this camshaft sensor and synchronizer shaft is fuel synchronization. So it syncs the fuel injection to the ignition. But the ignition timing is completely controlled by the computer. When you rotate this, you are not adjusting the ignition timing at all. So let me get the camera set up so I can get this to top dead center, and we'll go from there. Alright, that is coming up on top dead center. I'm just going to use a screwdriver to touch the top of the piston. I'm just watching to see when the screwdriver stops moving. Right there. You can actually see the top of the piston right there, and that there's 2 cycles of the engine to where the piston is at top dead center. One is the compression stroke, which is where you need to be, and the other is the exhaust stroke. So make sure that you're on the compression stroke. That was the whole point of putting your finger over the hole. When you crank it around, you'll feel that pressure trying to blow your finger off the hole. If you don't feel that, you're on the exhaust stroke. Connector off. I'm going to go ahead and take these 2 screws out. And these are, what is this? This is a 7/32. I don't know if all of them's going to be that. Probably depends on if yours is aftermarket, factory, or whatever. Now in the factory ones, there's actually a hole right here that they say stick a screwdriver in. Not a screwdriver, stick a toothpick in. And there's a hole in this little piece right here. Yeah, you can see how much play that has. That's the problem. But there's a hole in here. You stick a screwdriver all the way through. I'm not going to do that. I'm just going to take a look and see where this shield, I'm sure they got a name for it, but this little piece right here, the open part is lined up with this, and right here, the edge of that is almost right in the middle of the little groove right here for the screw. And like I said, we're going to use the scan tool to get this set right. So I'm not worried about, I'm not going to stick a toothpick through there, but by all means, go ahead and do that just to be on the safe side. I've noticed the new one does not have that hole, so there's not really a point in it. So I'm just going to have to eyeball. Actually, I think I'm going to go off this edge right here, because that edge is perfectly lined up with the edge of that U-shaped hole. So that's what I'm going to do. And I'll show you the difference between a wore out camshaft synchronizer and a good one. Let me get an air hose over here. And it should just come out now. So that right there is no good. Way too much play. You can actually see right here where it's been coming up and rubbing the top of the sensor, it looks like. But the main problem with this, let me see if I can get a good, see that the bushings wore out. Hopefully you're getting a good shot of that, or a good view. So let me show you what a good one should look like. So here's the new one. No side-to-side movement at all. And then the play right here might be 5/1000ths. So we know that this groove goes toward the rear of the engine. I need to move this over until that edge is just lined up with that hole. And if it won't drop in, you got to get down there and you got to just turn the oil shaft where this meshes in. Just turn it with a screwdriver to where it needs to go. So this is, yeah, it's quite a bit. It's quite a ways off. So I'm going to reach down there. right there. Perfect. And make sure your gasket is on it. I don't know if I showed the gasket, but there is a gasket on this shaft. I'm going to put the clamp on, but I'm not going to tighten it all the way up. And I should have showed that this one does not have that hole the way the factory one does. I'm just going to snug that up by hand. It should still allow me to move it, but it's not so loose that it's going to turn on its own. So at this point, the synchronizer shaft is installed. It is not tightened up yet because we have to use the scan tool to set it exactly where it needs to be. I'm going to go ahead and throw the spark plug back in. Here's the coil pack that just bolts on there with 4 bolts. Coil pack just bolts on with 4 bolts once you get all the boots on. And then once I get that done, I'll turn the camera back on and show you the scan tool and how we're going to set it. Alright guys, so the camshaft synchronizer is installed. Everything's hooked up, spark plugs are back in, coils are reinstalled. We're back here on the scan tool. And we're going to go here to powertrain. And this is the only way you can accurately set one of these. You have to have a scan tool. I see people on the internet just telling you to put the toothpick in or put a piece of wire in that hole, drop it back in, face it aft, and start it up. And if you're lucky, you'll be within range, but I'm going to show you how to get it perfect. So what we're going to do, first thing I want to do is we're going to start it up and we're going to read some data stream, and I'm going to go out there and rotate it just to show you that the timing does not change with it. Let me get everything picked out here. We'll go with when that O2 sensor really starts going, okay, it's got a pretty good signal there, up and down. So it's probably in closed loop. We got our temp is coming up. It's got to be in closed loop. So okay, you can see it says in sync on this page. Spark advance is about 10-ish. So let's go out here and rotate this. And what you're going to notice is that spark advance isn't going to change. It might change just for a second. Then the computer will readjust. So I'm just going to reach down, we'll rotate that. I'm going to rotate it some more. See, the computer is adjusting it on the fly. So I want to rotate it back so it runs better. Now, to get this set just perfect, this is what you got to do. We're going to go back, go to Special Function, Set Sync Signal. I'm going to hit that, hit OK. And if you notice right here it says not in range. Distributor setting, right now it's shown to be about 16 to 19. Sync spec is 0. Perfect is 0. So you want this reading to be as close to 0 as possible, and you want this to say in range. So I'm going to reach down here, and I'm just going to lightly turn it. I don't know which way I need to go yet. Okay, we're getting closer. This just went to in range. We're setting it at about 5 or 6. I'm going to go ahead and turn it some more to get it to hopefully 0. And there you have it. You want it to say in range, and you want this to 0. And this is warmed up. The idle is good now. It's purring like a kitten. In fact, what's it idle now? Right at about 1,000. That's probably a little bit on the high side, but we'll drive it and see what happens. Anyway, that's how you adjust that synchronizer shaft. Can't do it by ear. Can't do it by feel. Have to have a scan tool. And hopefully that's coming in good. In range and 0. And again, this was in the special functions of set sync 0. And now that I just got out of it, the idle just dropped down. So I guess it had the idle bumped up because it was in that mode. So the idle's sitting right on the money. It's idling good. In fact, let's go back to sync 0. Yeah, it bumps the idle up. I guess it wants the idle right at 1,000. Not sync 0, but set sync signal. Anyway, we're done. This thing's finished once I get the air filter all put back on. I guess the only last step is tighten her down. 13 millimeter. Alright, we're done. You guys take care.